Hi, my name is John, and welcome to our channel, Math is Fun. In this lesson, we will discuss how to evaluate algebraic expression. And before we start evaluating algebraic expressions, let's recall some important key vocabulary that would help us understand what an algebraic expression is. First is variable. When we say variable, it is a letter used to represent one or more numbers, like for example, 2x, where x is a variable, which means x can be used to represent one or more numbers. Second is exponent. When we say exponent, it corresponds to the number of times the base is used as a factor, like for example, pi r squared. 2 is an exponent of r, meaning we need to multiply whatever the value of r by itself twice. Third is power. When we say power, it is an expression that represents repeated multiplication of the same factor, like for example, y cubed. The whole expression y cubed is called power. Fourth is algebraic expression. When we say algebraic expression, it is an expression that contains one or more variables, like for example, 2x plus 1. In this case, the expression 2x plus 1 contains one variable, and that's x. Another example of an algebraic expression is 5y minus 3xy plus 8. If you notice, this expression has more than one variable. And to evaluate algebraic expression, we simply substitute each variable in the expression with the value assigned to it and simplify. Let's do some examples. Evaluate algebraic expressions when x equals 2. Let's have 4 algebraic expressions to evaluate using the same value of x, which is equal to 2. The first one is 6x, second is 10 over x, third is x plus 5, and fourth is 13 minus x. Let's start with 6x. To evaluate 6x when x equals 2, simply substitute x with its given value. So this is equal to 6 and then open and close parentheses 2. Remember, when the expression is written like this, 6 and then followed by the value of x enclosed in parentheses, it means that the operation to perform is multiplication. So 6 times 2 equals 12. Let's have the second example. 10 divided by x, or 10 over x. The same as what we do in example A, just substitute the value of x. So now it becomes 10 divided by 2. Simplifying 10 over 2, we get 5. Now let's have x plus 5. Again, substitute the value of x. So this becomes equal to 2 plus 5, and then simplify. The answer is 7. And lastly, we have 13 minus x. Following the same procedure, substitute x by 2, so this is equal to 13 minus 2. And 13 minus 2 equals 11. So, what can you say about evaluating algebraic expressions? It's very easy, right? Now let's have the second set of examples. Evaluate algebraic expressions when y equals negative 4. Again, let's have 4 algebraic expressions to evaluate. Y cubed, 5y squared, y to the 4th power over 8, and 5 minus 3y squared. Let's start with y cubed. By substituting the value of y, so we have equals negative 4 cubed. Make sure negative 4 is enclosed in parentheses. Lately we discussed about exponent. Here in this expression, the exponent is 3, meaning we need to multiply negative 4, the base by itself, 3 times. And to simplify this, we can rewrite this as negative 4 times negative 4 times negative 4, right? Actually, there are many ways on how to simplify negative 4 cubed. But what I will be showing you here is the step-by-step process in getting the answer. So you can start by pairing the first two factors, negative 4 and negative 4, and then multiply them. Remember that when you multiply a negative number times another negative number, the answer is always a positive number. So here, when you multiply negative 4 times negative 4, the answer is positive 16. And we'll multiply it to negative 4, the third factor. Take note that 16 is positive and 4 is negative. So when we multiply a positive number by a negative number, the result is always a negative number. So positive 16 times negative 4 equals negative 64. Before we proceed, I will give you a tip. When the base is negative, the answer could either be a positive number or a negative number. Why? Okay. The exponent will identify whether the answer is a positive number or a negative number. Always remember that if the exponent is an even number, the answer is always a positive number. But if the exponent is an odd number, the answer is always a negative number. Like in this example, the base is negative and the exponent is an odd number. So the result is negative number, negative 64. Let's have the second example, 5y squared. Again, by substituting the value of y equals negative 4, this is equal to 5 times negative 4 squared. Take note we enclose negative 4 in parentheses, just like what we do in the first example. Now be careful in simplifying this expression. Do not multiply 5 by negative 4 first, because you will get the wrong answer. Remember that every time you simplify algebraic expressions, always consider the PEMDAS rule. So what is PEMDAS? Okay, let's do a quick review. PEMDAS is an acronym that stands for parentheses, exponent, multiplication, division, addition, and subtraction. This is the order of operations that needs to be followed, meaning you need to simplify first the ones inside the parentheses, then followed by the ones with exponents. Then perform multiplication, and after that division, and then addition, and subtraction, the last one to perform. Now let's apply PEMDAS rule in this example. Let's start with the P for parentheses. Do we have something inside the parentheses that needs to be simplified? There is none, because negative 4 is already in its simplest form. In other words, we can skip the first order of operation P and proceed to E for exponent. Now, it has an exponent too, and as I have mentioned in the first example, when the base is negative and the exponent is an even number, the answer is a positive number. So multiplying negative 4 by itself twice, the answer is positive 16. So what is the next order of operation to perform? It's M, multiplication, right? So we can multiply them since the operation between 5 and 16 is multiplication. So positive 5 times positive 16 equals positive 80. So you might ask, what happens to the other order of operations? Division, addition, and subtraction. Now here, logically, nothing to do after we get the final answer, positive 80. Remember, we can no longer simplify positive 80. Now let's have y to the fourth power over 8. Again, substituting the value of y equals negative 4, we get equals negative 4 to the fourth power over 8. And following PEMDAS rule, do we have something inside the parentheses that needs to be simplified? There is none, right? Then proceed to E for exponent. Since the exponent is 4, meaning we need to multiply negative 4 by itself 4 times. And by multiplying negative 4 by itself 4 times, it will give us an answer of 256. Remember, the exponent is an even number, and therefore the answer must be a positive number. And since we have a denominator 8, so just copy 8. Next is M for multiplication. Do we have something to multiply? There is none, right? So proceed to D for division. And yes, we have something to divide. And by dividing 256 by positive 8, the answer is positive 32. So we stop from here since we already have the final answer. And let's have the last example. 5 minus 3y squared. Again, substitute the value of y. So this is equal to 5 minus 3 times negative 4 squared. Take note of the parentheses. Applying what we've learned from the previous examples using PEMDAS rule, negative 4 squared is equal to positive 16. Or if you want the detailed solution, then we can rewrite this to equals 5 minus 3 times negative 4 times negative 4. Simplifying negative 4 times negative 4, that's equal to positive 16. So this is equal to 5 minus 3 times 16. Now again, be careful. Do not subtract 5 by 3. Always use PEMDAS rule, and by following it, it means that we must perform first the multiplication before we'll do the subtraction. And before you will do that, take note that 3 is negative and 16 is positive. This equal to copy 5 and then multiply negative 3 by 16. The answer is negative 48. So it's minus 48. Now let's perform subtraction. 5 minus 48 is equal to negative 43. Now let's have another set of examples. Evaluate algebraic expressions when x equals 2, y equals 3, and z equals negative 4. Let's have some examples. 3x plus 2y, negative 5x plus 4y, and y squared minus xz over 8. Let's start with 3x plus 2y. Substituting the value of x and y, so this is equal to 3 times 2 plus 2 times 3. Again, don't forget PEMDAS rule. Multiplication must be performed first before the addition. So positive 3 times positive 2 equals 6. And then plus, and then positive 2 times positive 3, and that's also 6. So simplifying 6 plus 6 equals 12. Let's have the second example. Negative 5x plus 4y. Substituting the value of x and y, this becomes equals negative 5 times 2 plus 4 times 3. Like what we do in the previous example, so let's multiply negative 5 and 2. The answer is negative 10. Plus, also multiply positive 4 by positive 3, and the answer is 12. Now simplify negative 10 plus 12. The answer is 2. Let's proceed to the third example. Y squared minus xz over 8. Substituting the value of x, y, and z, so this is equal to 3 squared minus 2 times negative 4 over 8. Again, PEMDAS rule. So let's simplify first 3 squared, and that's 9. Copy the minus sign, and then multiply 2 by negative 4, and that's negative 8 over 8. So now copy 9 and simplify negative 8 over 8, which is equal to negative 1. So this is equal to 9 minus 1. Why negative? Because they're having unlike signs. Again, let's simplify. Copy positive 9. Now, what will happen with the two minus signs? Simplify them. Negative times negative is equal to positive. So meaning negative times negative 1 equals positive 1 or plus 1. So this is equal to 9 plus 1. And simplify 9 plus 1 equals 10. Let's have the fourth example. The quantity of y minus 2x squared plus yz. Let's solve this in two ways. Solution A equals the quantity of 3 minus 2 times 2 squared plus 3 times negative 4. If you notice here, we just replaced the variables with its corresponding value. Following PEMDAS rule, we must simplify first the ones inside the parentheses. So this is equal to open parentheses and then copy 3 and then simplify negative 2 times 2, which is equal to negative 4, and then close parentheses, squared. Then simplify positive 3 times negative 4, which is equal to negative 12. Again, here we can still simplify 3 minus 4, and that's equal to negative 1 squared, then copy minus 12. Now simplify negative 1 squared equals positive 1, then copy minus 12, then simplify 1 minus 12 equals negative 11. I will show you the other way of simplifying this algebraic expression. Solution B. This is equal to the quantity of 3 minus 2 times 2 squared plus 3 times negative 4. Notice that the first part of the first term of the expression has an exponent 2, meaning the base has to be used as a factor twice. Therefore, we can rewrite it to the quantity of 3 minus 2 times 2 times the quantity of 3 minus 2 times 2. And then simplify. Positive 3 times negative 4 equals negative 12. Again, simplifying the ones in the parentheses. So this is equal to the quantity of 3, and then multiply negative 2 by positive 2 equals negative 4 or minus 4, times the quantity of 3 minus 4, which is the same. And then minus 12. Simplify 3 minus 4, and that's negative 1, times negative 1 minus 12. By following PEMDAS rule, multiplication comes first before the subtraction. So let's multiply first negative 1 and negative 1. The answer is positive 1. Then copy minus 12. Now simplify 1 minus 12. The answer is negative 11. Now if you notice, both ways lead to the same answer. Actually, this could also be done using mental calculation, but if you're not that confident for now, I suggest to write the step-by-step solution. Now let's have another set of examples. Evaluate algebraic expressions when q equals negative 2, r equals 4, s equals negative 1, and t equals 3. I will present you here the first two examples, r plus s over t, and 3 times the quantity of r minus q minus rs. Let's take the first example, r plus s over t. Substituting the value of r, s, and t equals 4 plus negative 1 all over 3. Simplifying 4 plus negative 1, the answer is positive 3. So this is equal to 3 over 3. And by dividing, 3 divided by 3 equals 1. Let's move to the second example. Again, substitute the value of q, r, and s. This is equal to 3 times the quantity of 4 minus negative 2 minus 4 times negative 1. Simplifying first the ones in the parentheses. So this is equal to 3, and then open parentheses 4, and then negative times negative 2 equals positive 2. And then multiply negative 4 by negative 1. The answer is positive 4 or plus 4. Simplify 4 plus 2 equals 6. And this will be equals 3 times 6 plus 4. Multiplying 3 by 6 equals 18. Copy plus 4. Then 18 plus 4 equals 22. Let's have the last example. Find the area of a square whose side is 4 centimeters. In order to solve this problem, first is identify what is being asked and given in the problem. If you will read the problem again, it says, find the area of a square, which is obviously the unknown in the problem, and this is what we want to find, the area. And if you continue reading the statement, it says, whose side is 4 centimeters. which is obviously the fact or given in the problem. Since the problem itself is talking about the area of a square, then we can relate it to the formula in finding the area of a square, which is A equals S squared, where A is the area and S is the side. Using the formula A equals S squared, simply substitute the value of S, which is 4. Now we have equals 4 squared. And what is 4 squared? It's 16. Therefore, the area of a square is 16 square centimeters. Now let's proceed to a short quiz to practice your skill, and here it is. If you want to see the complete solution, you may go to the link indicated below or comment your answer on the comment section. If you like this video tutorial, don't forget to hit the like and subscribe button. Thank you for watching.